Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 5 from the GCE Core Mathematics C4 papers, and this is from January 2007, long time ago. It's an old paper, as you can see. Even this is the best print I could find for it. It's all faded and stuff. Now this is a question that I gave my students in like a practice paper I made for them for P4. And I think it's question number 8 from that paper, I'm not sure. Anyway, so this question is a question about implicit differentiation, all right? And we're told that there's a set of curves which is given by the equation sine x plus cosine of y equals 0.5. And we have to find an expression for dy dx. So we have to differentiate basically this expression with respect to x, and then we'll end up with a term dy dx in it, okay? And implicit differentiation is basically where you differentiate both sides of the equation with respect to x. So I'm differentiating the whole of this side with respect to x. So I've got the differential of sine x plus cosine y with respect to x. And what I do to one side, I do to the other. So I have to also differentiate this side also with respect to x. So I'm differentiating 0.5 with respect to x. All right. And when you differentiate some expression with respect to x, and it's made up of different terms, okay, you basically differentiate each term separately with respect to x. So I'm going to differentiate sine x with respect to x. I'm also going to differentiate cosine y with respect to x, and I'm going to differentiate 0.5 with respect to x. Now, all of these two lines that I've written down, you don't need to write them down. I'm just trying to give you the basis behind what implicit differentiation involves. All right, what you need to write down actually is from this third line. This is what you'd actually write down. I'm just trying to explain to you what implicit differentiation is by writing these two lines down. So what we're going to do now is we're going to differentiate sine x with respect to x, which we know is cosine x. We have cosine x plus, and if we differentiate cosine y with respect to x, well, we can think of this as y is some function of x. I can express y as some function of x, right? So if you think about it, if you have a function inside a function, okay, a function inside another function. So I've got f of x, f of gx. So I have a function inside another function, right? That's what we have. We have y inside the cosine function, the cosine of y, right? So this is the same situation, right? If you differentiate something like this, what you do is you differentiate the function as a whole. So this is going to be f dash of gx as it is. So I differentiate this as a whole, so I get minus sine of whatever it is as it is. And then I have to use the chain rule. I have to multiply by the differential of what's inside the function. So I have to multiply by the differential of this function with respect to x. So therefore I have to multiply by the differential of what's inside the function. The differential of y with respect to x, differential of y with respect to x is dy dx. That's what, by definition, right? So this gives us minus sine y dy dx. Okay, so that's what implicit differentiation is basically doing. You are using the chain rule. You are differentiating the main function. So differential of cosine y with respect to x gives you minus sine y. So this becomes minus sine of y. And then you differentiate y with respect to x. So that gives you dy dx, and you multiply it with this. This is the chain rule, basically. That's what implicit differentiation is. And that gives you 0. When you differentiate a constant, you get 0. Now we can make this dy dx the subject of this, and that will give us an expression for dy dx. So I'm going to add sine y to both sides. So I'll have cosine x equals sine y dy dx. And then I can divide both sides by sine y, end up with dy dx equals cosine x over sine y. And that is my answer to part A of this question. All right, cosine x over sine y. Now for part B, it says for x values between minus pi and pi and y value between minus pi and pi, find the coordinates of the points where dy dx is equal to 0. And this is the original equation of the curve that we differentiated. So we got here dy dx is equal to the cosine of x over the sine of y. Alright, now we want to make dy dx equals 0. Dy dx equals 0, so I'll say the cosine of x over the sine of y is equal to 0, which leads us to the equation the cosine of x equals 0. And we've got to do this between the limits of minus pi and pi. So if we think about the cosine curve between minus pi and pi looks something like this. Right? It hits 0 at pi over 2 and negative pi over 2, between minus pi and pi. That's the cosine curve. If I press inverse cosine, if I try to solve this equation, cosine x equals 0, if I put inverse cosine of 0, and I have my calculator in radian mode, I'm going to get x equals pi over 2. Sorry, pi over 2. And I know that there's another angle, which is 2 pi minus pi over 2, which is 3 pi over 2, which is further away out of the range. And I also know that the negative version of each of these positive angles is also going to be a solution, so I'm going to have negative pi over 2. Or I can say the angle that I found over here, which is 3 pi over 2, take away 2 pi, will give me minus pi over 2. So I end up with these two solutions. These are the two solutions for cosine x equals 0. Now we got to find what y is. All right. So let's take when x equals pi over 2. Let's see what happens for y. So I know that sine of x plus cosine of y equals 0.5. So I've got the sine of pi over 2 plus the cosine of y equals 0.5. I'm solving this, I'm replacing the x in the equation with pi over 2, and I'm finding out what y is from this equation, and then I'm going to have my coordinates, x and y. These are my x coordinates, and then I'll get my y coordinates from that. Now the sine of pi over 2 is a half. The sine of pi over 2 is 1, sorry. The sine of pi over 2 is 1. The sine of 90 degrees is 1. Okay, sine curve goes like this. Alright, so pi over 2 is over here. Okay, the sine of pi over 2 is 1, and the sine of minus pi over 2 is minus 1. Okay, so this is going to be 1 plus cosine of y equals 0.5. So I have cosine of y equals minus 0.5. So y is equal to the inverse cosine of minus 0.5. Now, if I put that in my calculator, the inverse cosine of minus 0.5, okay, what that gives me is an angle over here. Okay, and I'll show you if I get my calculator. I have to put it in radian mode. So shift, angle unit, radians. So if I press inverse cosine of minus 0.5, it gives me, I think, 2 pi over 3. That's right, 2 pi over 3. All right, because it's in this quadrant where it's negative, and it will give me, that will be the principal angle, 2 pi over 3. So 2 pi over 3, which is like, I think, 120 degrees. Right, but we're dealing with radians here because the limits in radians, and when you do trig and calculus, you must use radians. Now there's another solution as well, okay, in our range, which is between also minus pi and pi for y, which has the same answer, and that is the solution over here. That's between, if you go pi this way, you have to stop there, and you go pi this way, minus pi, you're going to get that solution as well, which is going to be minus 2 pi over 3. All right, so those are two solutions that come from pi over 2. Okay, so you have pi over 2 and 2 pi over 3, and you also have another solution which is valid, pi over 2 times minus 2 pi over 3. So those are two places where the gradient is equal to 0. Okay, that's like two turning points, you could say. All right, so those are two answers here. Then we got to try when x equals minus pi over 2. That was another solution we got. Now when x equals minus pi over 2, we have the sine of negative pi over 2 plus the cosine of y equals 0.5. Now the sine of negative pi over 2 is -1. So I have -1 plus cosine y equals 0.5 So when I add 1 to both sides, I get cosine y is equal to 1.5. Well, here we have no solution. No solution because the cosine curve, of course, never goes above 1. Right? It never goes above 1. So the cosine curve is this one, never goes above 1. Right? So therefore, the only solutions are these two. These are the turning points. These are where dy dx equals 0. Okay, so these points are where dy dx is equal to 0. And that is the answer to this question. Now, many people in this question, they only found this one solution. The ones that got as far as this, they only found this solution here. They didn't find that solution. But you see very clearly it says x is between minus pi and pi. Most of you, you know, got this solution and they didn't go on to get the other one. So, and then of course, this solution then leads on to these two solutions. So y is also between minus pi and pi. So, you know, this one solution here, this one value here, went on to find two, or give us two coordinates. Two coordinates, one here and one here, right? So that's something important for you to understand. Look at the limits, make sure you catch all the angles within those limits. So there's the answer to this question number 5 from this C4 paper. I think number 8 from the paper that I gave my students, the practice paper. So I hope that was clear. Other questions from this particular paper here can be found in the playlist that will appear in this section. Other questions from that practice paper I gave those students will be in this playlist. Other questions from implicit differentiation from P4 will be in this playlist over here, and you can subscribe to my channel by clicking on the link. Thank you for watching and see you soon.